from this battery should be so the voltage from a zinc iron battery should be, can't be negative. For batteries, it's got to be positive. Okay, so if zinc is going to be your anode, zinc is going to be oxidized. So what we want to do is change the sign from minus 0.76 to plus 0.76. So we have plus 0.76 minus 0.44. So we have plus 0.76 minus 0.44. And that's equal to plus 0.32 volts. So this should be the voltage of the zinc iron battery. Okay, so we'll do more of this in lab. We'll do this slide on. Let's do this slide on Thursday, because we'll look at table 19.1 again to figure out oxidizing agents, reducing agents. But let's review this slide. So a voltaic cell uses chemical energy to make electrical energy. An electrolytic cell uses electrical energy to make chemical energy. We looked at this equation just a few minutes ago. Now, which cell type produces energy? Voltaic or electrolytic? Okay, so it's the eeny, meeny, miny, mo.
Energy to activation.
Heads is voltaic, tails is electrolytic. So which one? So is this one or that one? So the cell type which produces energy is the...
That one.
Who says it's this one which is voltaic? Who says it's that one which is electrolytic? Okay, so voltaic is the correct answer. Okay, so note that a voltaic cell uses chemical energy to make electrical. So note that energy is produced in this voltaic cell. For part B, which type involves a spontaneous reaction? The voltaic or electrolytic cell?
Voltaic.
So for part B, who says voltaic? Who says electrolytic? Okay, so for part B, the answer is voltaic. So again, note that based on this equation, if E cell for a battery or voltaic cell is positive, delta G is negative, which means that that reaction occurs spontaneously. Okay, so again, for parts A and B, those are voltaic cells. Which cell type requires energy?
Electrolytic.
Yes, electrolytic cell, because we have to supply electrical energy to make a chemical reaction occur. That is a non-spontaneous chemical reaction occur. Which cell type has a positive E cell?
Voltaic.
That's a voltaic cell. Which type requires a salt bridge to separate the anode from the cathode? And that's a voltaic. That's that battery. Let's review one more slide. So this is from your physics class. So here's some electricity terms. So we know that energy is equal to charge times voltage. So energy is in joules, charge is in coulombs. That's the charge of an electron. Voltage is in units of volts. Here's another equation. Current is equal to charge divided by time. So I is equal to Q divided by T. So current is in units of amps or amperes. Coulombs is charge in units of coulombs. So coulomb per second is an ampere. Okay, so note that current really is the amount of charge which flows past a point in a certain period of time. Voltage, this is Ohm's law, is equal to current times resistance V equals IR. So volt is equal to amperes times ohms. And then power is energy divided by time. So a watt is a unit of power. Energy is joules. Time is in seconds. So a joule per second is a watt. And then In electricity, power is equal to current times voltage, so an amp times a volt is also equal to a watt. Now, note that current is like the size of water pipe, so note that if you have a bigger water pipe, that means you can pass more current through that water pipe. So really the thicker gauge wire, that means you can pass more current through that wire. Or that's like broadband versus dial-up, so note that broadband, a lot of information, a lot of current flows through that pipe versus dial-up, which is a really thin wire or thin pipe. Guys know a good analogy for voltage? So that voltage, you've seen this in your physics class. And don't tell your physics instructor, Dr. Haig, that we talked about this in chemistry, because I don't want her to tell me that I'm explaining this the wrong way. Okay, so you have two plates, one's a positive plate, one's a negative plate. So note that if you have some charge, which this is some charge which we can represent by Q, which is, you know, the coulomb. So note that if you have some negatively charged particle there, you've got to have a certain potential difference for this charge to move from the negative plate to the positive plate. So what does all that mean in terms of voltage? I was trying to think of an analogy at midnight last night. I figured I can't think of one. This too. I'm going to look at it. I was too tired. That's why I couldn't think. That's why I'm asking you to fill in that blank. So it's a good analogy for voltage. Okay, so I guess I'll see you guys. I don't think it was.